The last example that we're going to do is a Boolean function that has 3 variables again. So do this one with me. So get a copy. I've put some images of these Karnaugh maps in Canvas, so you can download and use those if you'd like, or you can write on a piece of paper and draw them yourself. So whichever way works best for you, go ahead and figure out how to write a Karnaugh map. And then let's do this together. So just pause this while you get ready, and then we'll do it together. So the first one is where x is 0, y is 0, and z is 1. So x is 0, y is 0, and z is 1. The next one is x 0, y 1, and z 0. It's that one right there. Next one is where x is 1 and y and z are both 0. So there, that's that corner one. Where the next one is where x is 1 and y is 1 and z is 0. Okay, so it's that one right there. And we have 1, 2, 3, 4 on the Karnaugh map and 1, 2, 3, 4 on the Boolean function. All right, so we've got 4. And let's go ahead and make groups, right? So first step is to map. The next step is to make groups. So I'm going to change the color here and make a group. Now notice that this one right here is all by itself. It's not connected to anything. It's not adjacent to anything. So this is going to be a group of 1. Sometimes we're stuck with that if there's nothing adjacent. It's the biggest group we can find for that one. Now this group over here is a group of 2. So we can do that one in a group of 2. Now this one looks like it's a group of 1. Do you remember though that I said something about that the Karnaugh maps wrap? And so they can be adjacent even if they're on opposite sides. So if we think about that this line wraps around to this line, so this edge is connected to this edge, and that makes this one adjacent to this one. So this one right here is adjacent to this one right here. And that's because Karnaugh maps wrap. And so this is a trickier one to find the groups. You have to know that detail about Karnaugh maps. And that means we have a group of 2 because these are adjacent. And so I'm going to make a group of 2 out of these because 2 is bigger than 1 and we want to make them as big as possible. And I'm going to draw it like that and say, okay, well, that's a group of 2 that way. All right, so that's step number 2 is to make the largest groups possible using groups either 1, 2, 4, 8, or so forth. And then we want to write the terms. So if we look at this term, notice that the x doesn't change, and it's the complement of x because it's 0. So I'm going to write the complement of x. Oops, I'm going to change that to black. It's a little bit easier to see. So the complement of x, and this time I'm going to, instead of use the bar, I'm going to use the quote. So that's the complement of x. Y doesn't change. It's also a 0, so it's the complement of y. And then z is a 1. And so it doesn't change, and it's the z because it's a 1. So notice when you have 3 variables and it's a group of 1, it's going to have 3, right? It's 3 variables in the product. So that's the first term. Let's do this next group over here. And notice that x changes. In the top one it's 0, in the bottom one it's 1, so we won't use x. Y stays the same. It's always a 1, so we'll use y. Z stays the same. It's always a 0, so we'll use the complement of z. And I don't care whether you use a bar or the single quote, just be consistent inside an individual expression. So that's the term for this other group. Now what about this group that is adjacent on the edges? We still look at the exact same thing. Notice that in both cases x is a 1, so it doesn't change, so we're going to use the x. And then we look, in this case, the y is 0, in this case, y is 1. So y changes, we won't use it. In this one, z is 0, and in this one, z is 0. So z doesn't change, so we'll use that one. So, and since it's a 0, it will be the complement of z. So that's the expression that goes with that group. So now we have the 3 groups. We've written an expression for the 3 groups, and so we connect them with an addition operator. 1 there, and 1 there, and we have the expression. Let's see how we did. And complement of x times the complement of y times z plus y times the complement of z plus x times the complement of z. And there we did it again. So that's another Karnaugh map, a handy tool for making more simple expressions.